Welcome to the Parker booth here at Bauma 2025. Parker Hannifin is proud to be the global leader in motion and control technologies. And here at Bauma, the motto is technology inside to make your world move. That moves your world indeed. So Parker is here to fulfill your wildest engineering dreams and to partner with OEMs for mobile machinery and off-road applications. What that means is that together we want to find the solutions for greater efficiency, improved safety and intelligence in your off-road applications, and doing all that while reducing emissions. No small feat. For our live talks here at Bauma, we have gathered our top experts from around the globe, and they will be sharing their insights on 4 key themes here at the booth. Those are clean tech, electrification, digitalization, and mobile hydraulics. And if you look around the booth, that's how it's organized here in order to answer the challenges that our customers are facing. So next up, we're going to be talking about heat, what it does to your mobile machinery, and how, thanks to thermal management, you can control that topic. Incredible but true, our 2 experts here today have nearly half a century of experience in mobile machinery each. And it's my pleasure to introduce them. First up, he is Division Market Manager at Parker's CADE, which stands for Cylinder, Accumulator, and Cooler Division. And he will be sharing his expertise in thermal management, in components and systems with us. He's passionate about driving the next steps in electrification and digitalization with Parker's customers, and he's happy to be back at Bauma. Please join me in welcoming Andreas Lengnowski.
Thank you.
And our second speaker is another huge fan of Bauma, which he has visited innumerable times, more times than you can remember.
Correct.
In your 36 years in the hydraulic industry. At Parker's hydraulic pump and motor division, he helps customers discover innovations in their systems to upgrade their mobile applications. Bienvenue, Blaise Goupy.
Thank you. Merci.
So great to have you both here, your concentrated experience. After the chat, we will have time for your questions, or perhaps even during. If there's anything you'd like to ask, do raise your hand. That's what our experts are here for.
Yep.
So let's get cracking.
Let's go.
What is thermal management in mobile work machines, and why is it important? Blaise, that question was for you.
Well, that was-
You was the speaker.
All right. Well, cooling is so important because indeed heat dissipation is potential problems because you can decrease the viscosity. So for the hydraulic system, it is a problem. It can damage the seals, and damaging the seals, it can create a leak. And in mobile machines, you don't want leaks that lead to fire. So that's why thermal management is important for the overall efficiency, but you understand also for a lot of safety features.
Would you like to add anything to that, Andreas?
Yeah, I think it's not. We have the hydraulic side and we have the cooling for this water glycol on the inverters, on the motors, on the chargers. So that's the same transforming energy. It's wasted energy, and we need to do it very quick, and we do it in a very efficient and density way. Why? We have waste material and we spend energy for it, and that's not need to be very efficient. So that's mean the heat transfer, what you say, it's important. It's for the oil side or the water glycol side, the important part, that I bring the thermal transfer very easy and efficient on the point. And this in a small space. Well, this is the other very important topic. On the new machines, more complexity join the machine, and the space is every time limited. And engineering capacity to get all the new technologies are really complex. We do it easy to use and easy to install. So that's maybe one topic what join us every day.
Thank you, Andreas. So you've touched upon it. Various components need to work simultaneously for the thermal management system to work. How does Parker ensure that all the necessary components work together optimally?
I think we have the opportunity that we know what the division A or my division or other division or the engineers have done. So we deep dive inside the elements and we know where are the limitations. So we can talk on a very experienced level to each other and find the best, efficient way to reduce size and increase the efficiency of the whole system. And that's quite unique.
Blaise, anything you'd like to add to that? How does Parker make sure all the components are working together optimally?
So we managed to have also some subsystems, that integrate valves, sensors, and different components such as the hydraulic motor. So that's an easy way to make sure that everything is combined. And with these different functions, we're able to control the speed that is needed for the airflow to have a good and decent temperature control.
Yeah. And you see it here on the picture. We go over different technologies. So that means when customer come to us, he is not limited that we have only the parts inside a fan drive with electric one, a hydraulic one, a low voltage, high voltage. So everything, it's inside our competence and inside the product we can offer. So that means when the customer come to us with different deep question about I have this very powerful part and I need more torque on my fan, then maybe we have the offering on a hydraulic motor what's driven by a electric EPTO system, and then you have a very compact, very efficient part. When it's come, we need more high voltage system, we have no space, but we want to stay in the architecture of battery. Yes, then we have the 800 volt fan drive system. So everything, it's an answer from us for the request of the customer.
Okay, what about energy consumption? How does Parker's thermal management contribute to reducing energy consumption and improving the environmental footprint of mobile work machines?
All right, so this is cooling on demand. So before,
it's
this is cooling on demand.
Right.
So before, it was mechanically driven fan.
Yeah.
So you had the big engine, 300, 400 horsepower. And when you needed 10 horsepower of cooling, you would raise the engine RPM. So a couple of years ago, it was decided to say, let's leave it at idle speed. And let's use hydraulics or electric to cool when we want it and what we want. So that was the big evolution. So that's what we would call cooling on demand.
And the good thing is that we have the whole architecture of the cooling circle in our competence. That means when we talk to customer and they see, okay, the mass is the driver to suck energy in. The liquid is the transport element for the energy. So that means we have the pumps for it, we have the connectors for it, we have the sensoric and the controls for it. So we can bring the cooling on demand on a level that you get exactly at the time you need it, the cooling you have to do. That's not overcooling, not undercooling, a precise cooling. And that's helped to reduce the consumption of the batteries and the whole efficiency of the system. And it is smart and it's easy. Why we don't need 1000 sensoric, we can handle everything while we know the physics in the systems. Then maybe 1 or 2 sensors is enough to understand and control the system very efficient.
Okay, can you think, without naming the customers necessarily, but can you think of a specific project where you use these products?
Of course. So
and why you chose those products for that?
That's it. And why we have been chosen by the customers.
Yeah, and that too, yes.
So indeed, different machines, different requirements. And this is where Parker is strong, is that we have different options, technological options, and even in the same technology, electric, for example, you have different solutions. Hydraulics, you have a lot of different solutions. So some customers indeed came to us and wanted to have a compact solution. So this is, I think, what you see here on the middle part, where we have squeezed the hydraulic motor, the M5 that is presented here on the booth, and you have this between the impeller and the radiator, because they wanted to be able to open it and have an easy maintenance. So which is true for an articulated dump truck, could be not true for another construction machine. And this is where we have to be clever, is to be able to propose different solutions, and then ultimately the customer chooses technology, design, and whatever.
But you also saying there are other factors that customer has to
I think-
consider space is your main space and power.
But Blaise raised this up. The space that's the cooler need to be very flat. So that's why Blaise integrate, or the team integrate the fan motor inside the design. So it's a very flat. The same concept we have is the high voltage. It's a flat fit cooler. Why? The space is really limited. When you have a big battery, then mostly the cooler is behind the battery. And when the battery and the cooler is too close to each other, you lost efficiency. So that's mean every space I get in the design, I make the system better. So this is the opportunity we have, that we play with a square fit or a flat fit. So that's give the exactly value in the design of the customer. And this helped the customer to get his machine efficient on the road.
What is the biggest mistake that you see customers making in their thermal management?
You ask me?
Yeah.
I will say, what is the mistake we did? That we thinking density is everything. So what we learn, it's really that the space is more effective than any density of the system. There's much more complexity on how can I bring all the parts in a system together. So that's the first question. Why you have a design engineer, he have a machine, and then you see, oh, this cooler I need, and there is the battery I need, and all have to fit in this space. So that's really the challenge. And then after this, it's the calculation of the efficiency. So how long can my machine operate? The thermal management is a small part from it. But when when we talk to our hydraulic colleagues, the hydraulic system is one of the consumer and consume the energy from the battery. When I make the hydraulic better and I make the cooling better, the complete working hours are longer. So that's important that we understand where the customer want to be. And that's maybe a couple of questions the customer have to ask his customer. The customer's customer, what he like to use this machine, what is the kind of last loads he want to do. And maybe there is a couple of things where we can learn that maybe our specs and the reality not every time fit. Mm-hmm. So that means we need to be more open to see, is the 45 degrees, how many days available on the ambient temperature? And how many I have to cool, how many I have to reduce? Is this really my driver? Or is it better to say, okay, I design it a little bit smaller, and then I can use it on 40 degrees and a little bit reduce on 45. So that's maybe, from my point of view, one of the lessons I learned. We need to talk deeper with the customer. What is the really need of his customers?
Mm-hmm. Okay, what do you see as the biggest mistake that customers make in their decisions for thermal management?
It's probably a lack of anticipation of what's coming. Because today, for example, we see more and more electrified functions, and electrified functions create less heat.
Yeah.
And if they create less heat, then we have to cool less. So that means that things can become much smaller. And that's where we have to make sure that we really understand what's going on. Each customer is different. Each machine designer has its own views. So we need to really understand what are the needs, and how can we find the solutions that are the most appropriate in terms of design, performance, noise, you name them. There's a lot of different areas. So as you said, it is about the customer's needs and the unmet needs that sometimes customers don't tell us. And that's why it's good to come on the booths, because we're going to visit some salespeople and we're going to ask them, what are the arguments? When you sell such a machine, what are the arguments and what are the issues that you would like us to solve? So that's why we're here, is also to open up and try to understand what's behind the scenes.
Okay, one more customer story that you can share where they've benefited from implementing your thermal management solutions.
I can say very easy. We see it here on the booth. So that's EPTO. That's it's a inverter, a motor, a pump, and a complete cooling system. So that's we developed a system what's worked perfectly to each other. We understand the customer's need on this application, and we give a one-stop shop opportunity to the customer. We know it will be smaller, it will be maybe fit good to his requirements, and it is easy to install, while we have a kind of plug and run solution for him. So that's mean it is for him easy to use, and that was a good success on truck market. So that we have there really a kind of one-stop shop element for customer, in this case of EPTOs.
Okay. Any other case studies that you can share with us,
Yeah,
Blaise?
we have a good one, because at first in the cooling designs, it was let's pick something that exists in our product range and let's just name it a cooling motor. And then we went the other way around. We visited customers and tried to get the unmet needs, and we designed the motor upon these requirements. So this means that the motor that we show right here is a motor that was designed specifically for cooling, with all the little things that were giving a hard time to the customer. So, for example, you have a shaft. We have put a tapered shaft so that when you're on the assembly line, you just put it in, pneumatic wrench, and in seconds it's installed. Because that's part of it. It's when you we had 13 components, and we've put all these 13 in one. So it's also the logistics, the supply chain. John Deere told us that one reference cost them administratively $10,000 per year, because you need the drawing, you need the installation, you need the check, you need the location. So that's a lot of hidden admin costs. So by having just one component, it simplifies a lot. And that's thanks to integrating the sensors we talked about, the valves, and all these different items. It's also quality-wise, you don't have leaks. And if ever you have a problem, it's a Parker problem, because all is in one. And so that's where we have seen big advantages. So time to install, different options that, I don't know how to say this politely, they used to say dummy-proof. That means that anybody can assemble it, because everything is designed so that you can only put this hose here, this connector here. You cannot mix anything. So that means reliability and quality on the assembly line from one machine to another. So that's the type of example that we can share.
So in a nutshell, you reduce complexity, reduce energy consumption, increase safety.
Increase safety, avoiding fires, you're
And-
correct.
Yeah. In a nutshell, wonderful to work with
Yeah.
You're right.
for thermal management solutions. Do we have any questions from the floor? Any questions you'd like to ask our experts about thermal management in your mobile machinery? Okay.
Good.
So if I'm taking a look around the booth and I want to know more about your thermal management solutions, which is the one product that you would lead me to as a highlight here at Bauma?
From my point of view, we have for our thermal management solution the EPDO directly here, close to here, where we showcase how easy you get a plug and run solution. And maybe a 850 volt cooler, you see it on the screen. It's in the front of the booth on the other side. So that's maybe the two elements what really can help customer to be in one modular system with a easy to use system.
That's the 850 VDC here.
Exactly, the flat fit is 850. Yeah.
Okay, and that's over on the electrification?
No, that's on the hydraulic side.
On the hydraulic.
Yeah.
On my side. Okay. Anything that you would highlight, Blaise?
On the hydraulic side, the hydraulic motor.
Okay.
Very simple, very simple.
Okay, well, thank you for sharing your insights. It's been wonderful to talk to you. Andreas and Blaise, I wish you all the best for the rest of Bauma.
Thank you very much.
Thank you very much.
Thank you.
Thank you, everyone. Bye-bye.